Hi everyone, thanks for watching. In this video, I'm going to show you how to tell if an atom will be stable or unstable by looking at how many protons and neutrons are in the nucleus. Let's start off by just kind of generally stating that an atom stability is determined by the quantities. That's how many protons there are versus how many neutrons there are in the nucleus, which makes sense kind of. That's why it's called nuclear stability. If we look at sort of three sample carbon atoms here, the first one with 6 protons and 6 neutrons would happen to be stable, whereas the other two, as the neutrons change, becomes less stable, and the carbon-14 with 8 neutrons would be the least stable out of the three. The next thing you might be wondering is, what does it even mean to be stable or unstable for an atom? If you're a stable nucleus, nothing really happens at all. You're already stable. You don't have to change. You don't do anything except exist in your current form. If you're an unstable nucleus, however, it means you do change. The word we use for unstable nuclei is that they decay, which means they break apart, oftentimes in the process, shooting out other smaller particles like protons and neutrons in the process. The next question is going to be, well, how do you tell? How do you predict if a nucleus is going to be stable or unstable? You know it's based on protons and neutrons, but maybe there's some actual rules there we can look at so you can tell for any nucleus. To do this, we're actually going to make a graph. And some people don't like graphs or anything having to do with math, but this is a nice simple one. All we're going to do is graph protons on the horizontal axis and neutrons on the vertical. And then what we're going to do is to mark a point on the graph every time there's a proton-neutron combination that is stable. So we'll start with carbon, the one we've already looked at. For carbon, the only stable, really stable nucleus is when there's 6 protons with 6 neutrons. So I count in 6 protons, 6 neutrons, put a green dot to mark that that is a stable nucleus for carbon. And if we keep doing this, marking these green dots, let's say there's 2 protons in a nucleus, it's going to be stable with 2 neutrons. If there's 3 protons, it's going to be stable with 3 neutrons. This one also works with 4 neutrons, however, it's stable that way too. And we keep putting green dots where it's going to be stable, and a pretty obvious trend emerges. You can eventually see that for small nuclei, the ones we've seen so far, for every 1 proton, it requires about 1 neutron to achieve a stable nucleus. That's why carbon was stable with 6 protons and 6 neutrons. We see a pretty obvious trend emerge. And it would be really nice if this trend continued for all atomic nuclei, but unfortunately it doesn't. As nuclei get larger and larger, the trend actually changes. So to see that, I'm going to mark out a line so we can always find the point where protons equal neutrons. Our small nuclei fall right along that line. That's where they're going to be stable. But if I fill in larger stable nuclei, you can see they kind of deviate from that. And if I switch graphs, so get ready, it's kind of going to change a little bit. Same idea though, all these dots are like my green dots. They represent the stable nuclei. You can see it starts to curve way upwards away from that line where the protons equaled out the neutrons. And what you're seeing happen here is that for much larger nuclei, for every 1 proton, it actually requires many other neutrons to achieve a stable nucleus. If we took, say, here 60 protons, for example, and you follow it up to where one of its stable nuclei would be, it's not 60 neutrons, it's upward around 80 to 100 neutrons to achieve stability. So that's how the trend changes for larger nuclei. We should also mention that this region here where all the stable nuclei can be found has a name. It's a very fitting name. We call it the band of stability. Let's end by returning to the original question. How can you tell if a nucleus will be stable or unstable? Simple answer, just check the band of stability. If it lies within that band, then yeah, it's probably going to be stable. So let's take a look at this question. What if we had an atom of mercury? Would it be stable or unstable with 90 neutrons? So you'd probably need a periodic table to find mercury and see that it has 80 protons. So you find 80, follow it a line up, find 90 on the neutron side and see where they meet. Since it is not in the band of stability, it's outside that range, no, this nucleus would not be stable. You could also say that that atom of mercury, in order to be stable, would have to be up in this range, probably at somewhere around 120 neutrons to achieve stability. That's it for this video. Thank you very much for watching.